carbohydrates has been further classified into reducing and non-reducing sugars. So this is what you are seeing now is a reducing and reducing sugar. First of all, whether all the carbohydrates or comes into the classifications of reducing and non-reducing, yes. Either it should be a reducing or it should be a non-reducing. Then how can you say based on three what we are already classified, that is monosaccharides, oligosaccharides and polysaccharides, among them, how can you say this belongs to reducing agent and non-reducing agent? Or if some of the molecule is attaining reducing, whether it is belongs to monosaccharides or disaccharides or polysaccharides. So these two ways of question you can ask in this question. One is how can you say all the carbohydrates are seems to be reducing or it should be non-reducing? That's the first point. And second point, whether this reducing or non-reducing will comes under any one of the classifications of this of monosaccharides, disaccharides, sorry, monosaccharides, oligosaccharides or polysaccharides, or you can say in a ulta way, that is in another way, that is whether in which of the reducing agent will comes to which groups. Okay. So first, reducing agent, sorry, reducing sugar. Sorry, I'm repeatedly using the word that is not an agent, that is sugar. So reducing sugar is an carbohydrate molecule which you can see a number or a presence of free OH group. That is the definition for reducing agent. If it is the free OH group is present in your anomeric carbon, you please note down the definition. I'll explain the each and word. First, you should know the reducing agent means it is present in a molecule where the OH group should be free. Okay, the OH group should be free for your or in your anomeric carbon. You can say, now I'll explain. So you can see here the number of OH groups are free, but does it, as we are informing, all the sugars, all the carbohydrates are having OH free group? Then how can you say some molecules are belongs to reducing or some molecules are belonging to non-reducing? How can you say that? So yes, I'm saying it's that OH group should be free in your anomeric carbon, not in all the carbon. Are you getting my point? It should be free in your anomeric carbon. What do you mean anomer or anomeric carbon means to say what? So anomeric carbon means it's an carbon atom, but the carbon atom should attach with the four different groups or four different functional groups should be attached to it. It means to say this, see, this is your carbon. Okay, the carbon, oh, sorry. The carbon, what you are seeing here, this carbon is attached with the four different groups. See, here it's O, here C, one more side it's of H, one more is O bonding, that is glycosidic bond. Okay, just see this carbon. We can say it's a chiral carbon also. We can say it is chiral carbon also. You just note this carbon. Okay, try to see whether it is attached to four different groups or not. Okay, so this is one carbon and it's attached with one more carbon, this side O, but again this side it's C, so it's ruled out. This carbon, here also carbon, here also carbon, no chance. This, here also carbon, here also carbon, no chance. Here this one, here also carbon, here also carbon, no chance. Here this is the only one carbon. You can say it's of anomeric in form. So wherever the glycosidic is going to be formed, the point or a carbon which attached to the which attach to the one more sugar group, or it may be a monosaccharide or disaccharide, whatever. It links to glycosidic bond. Okay, it's linked to glycosidic bond. That carbon is seems to be anomer. I'll explain again. In the all carbohydrates, like all carbon of your glucose, let us take the example of glucose. Okay, let us take the example of glucose. Okay, just a second. I'll ಒಂದು ನಿಮಿಷ ಅನೋಟೇಟ್ ಮಾಡ್ತೀನಿ, ನಾನು ಗೊತ್ತಾಗುತ್ತೆ. ನಾನು ಒಂದೇ ಒಂದು ಸೆಕೆಂಡ್ ಫೋನಲ್ಲಿ ಲಾಗಿನ್ ಆಗ್ಬಿಡ್ತೀನಿ.
So here we need to take the carbon. That carbon should be, okay, that carbon should be yes, that carbon should be chiral. So chiral means to say what? What do you mean by chiral carbon atom? You just please see the carbon numbers. I am giving the number over here. It is 1, 2, 3, 4, 5, 6. So if it is the carbon should be chiral, then it should attach with the 4 different groups in 4 directions. 4 ಬೇರೆ ಬೇರೆ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅಟ್ಯಾಚ್ ಆಗಿರಬೇಕು. ಸೊ ಅದನ್ನ ನಾವು ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತ ಕರಿತೀವಿ. ಬಟ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ರೆಡ್ಯೂಸಿಂಗ್ ಶುಗರ್ ಅದನ್ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಬೇಕು. ವಿ ಆರ್ ಸೇಯಿಂಗ್ ದಟ್ ಇಟ್ ಆಸ್ anomers ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ, suppose how I am saying is, if this carbon it is attached to and one more carbon, right? So then one here O2, but here ಇನ್ನೊಂದೇನಾಗಿದೆ ಇಲ್ಲಿ O double bond O ಇದೆ. So that's why it is not a 4 different group, only 3 different group ಇದೆ. So this carbon 1 is ruled out, it's wrong. Then let us see the second carbon. So second carbon is, yes, of course it is chiral. Chiral ಯಾಕೆ ಹೇಳ್ತೀವಿ? 4 different group ಇದೆ. So is it? So 4 different groups are there. But here let us see the what are the atoms which attached. I am saying one carbon having the capacity of giving 4 electrons. So it can combine with 4 groups of atoms. It may be the same, means to say hydrogen can be attached in the 2 number. 2 hydrogen attach ಆಗಿರಬಹುದು. But what do you mean by chirality? Chiral carbon means to say that 4 atoms should be in a different manner. If it is different, then you can say it is chiral. If it is same, it is not chiral. Okay. So let us see the second carbon. The first one, like one side attached to carbon, but second side in the other side also it attached to carbon. So it is ruled out. It's wrong. Then you can see the third one. Okay, third one HOH, right? But up and down it's carbon, so it's also wrong. So here HOH, right? But up and down it's carbon. So one having only 3, 2, 3, 4 having a 2 carbon, so it is not a chiral. Let us see the fifth one. Fifth one also having the 2 carbon on one side, but here fifth carbons can be said it as chiral. Why? Because this CH2OH is considered as an functional group. ಇದನ್ನ ಪೂರ್ತಿ ಅಂದ್ರೆ ಏನು, CH2OH ಪೂರ್ತಿ ನಾವು ಒಂದು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಆಗಿ ತಗೋತಾ ಇದೀವಿ. ಸೊ ವಿ ಆರ್ ಕನ್ಸಿಡರಿಂಗ್ ದಟ್ ಎಂಟೈರ್ CH2OH is seems to be in the terms of functional group. That's why the carbon 5 can be said it as chiral carbon. So same like that in your ring structure, how we were writing here. Okay, how we are writing up here. It's a H, OH, OH, H, OH, H, H, OH, H, CH2 OH. Alva ring structure ಈ ತರ ಬರುತ್ತೆ ನೋಡಿ. So this ring structure also having, this is the carbon 5. So this having the chirality. So that's why if the atom is comes under the classification of reducing or non-reducing sugar, we need to see the carbon. That carbon should be anomeric in form. Okay, that carbon should be anomeric in form. So then you can say that this carbon, if it is in this carbon, OH group, if it is free, okay, OH group, if it is free, you can say that is an reducing sugar. I'll show you one more thing now. So let us see one disaccharide structure. One disaccharide structure bariyana. Okay, this is fast. This is 1, 2, 3, 4. Okay, H, OH. Same. Ulta ಮಾಡಿದೀವಿ ಇಲ್ಲಿ. OH, H, H, OH, OH, H. CH2OH, H. Same. CH2OH, H, OH, H, H, OH, H, OH. Okay. So these are the two glucose. This is one glucose unit. This is second one glucose unit. Okay, these are the two glucose. So we need to make the bond in between these two glucose. So ಈ ಎರಡು glucose ಗಳ ಮಧ್ಯೆ we need to make a bond. So how to make this bond? We are just taking the first and fourth carbon of the adjacent two glucose. ಎರಡು glucose ಇನ್ನ one first one ಮತ್ತೆ fourth one carbon ಅನ್ನ adjacent ಅಲ್ಲಿ then it gives like two molecules of OH. Then we are remove the two molecules of OH and we are made it of H2O. Okay. So what does it remain? So H2O will produce, and what does it remain? It remains only. So here OH2 molecules are there. So it means to say O2H2. Among this, one molecules of H2O will form. Remaining one O is forming an glycosidic bond between these two glucose. That's why two glucose monomeric units leads to formation of your sucrose. Okay, sucrose. So sucrose seems to be disaccharide, and these disaccharides are formed by two glucose units by the addition of 1,4 glycosidic linkage. So ಇದರಲ್ಲಿ ನಾವು we need to say it as alpha or beta. Okay, alpha or beta. So if it is like this, ಈ ತರ bond ಇದ್ರೆ this alpha. Um, just a second. About if it is the bond is like this. Okay, if the bond is like N, it is beta. If it is like U, it is alpha. Okay, alpha and beta bonds. So are you getting now? So this is the first point. So let us see how we can say whether it is reducing or not reducing. Now you are you know how to write the structure and all things. So as I inform you here, H's are remaining and here OH, OH, same. Everything remains the same. But here I told you this 1 and 4th carbon may be the possibilities of anomeric form because it attached to the 4 different groups, right? So now whether these carbons having OH group or not, if it is OH group is present, if it is OH group is present here, it is reducing sugar. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Anomeric carbon ಅಂದ್ರೆ ಏನು? That carbon should be attached to the 4 different groups. 4 different group attached agide, that is anomeric carbon. If that carbon after formation of glycosidic bond, if it is present or presence of OH group, it shows you the reducing sugar property. It shows you the reducing sugar property. And next one, if in case, okay, if in case, ma'am, you are saying about disaccharides, that is fine. Disaccharides having, now we got clear that disaccharides is if it is contain OH group in the anomeric carbon, it is reducing. If not, it is not reducing. That's fine. But as you inform, glucose also having an anomeric carbon that is in the position of 5. Yes, of course, right. And that may be the reducing sugar. That why can't that become a reducing sugar? Yes, it will become a reducing sugar. And you know one thing, all the monomeric saccharides, all the monosaccharides or comes under the classifications of reducing sugar. All the monosaccharides comes under the classifications of reducing sugar, but disaccharides only sucrose is your non-reducing sugar. Your lactose and maltose is your reducing sugar, because once you write the bond structure, you will get one OH group, because those two having the beta glycosidic linkage. So you can say if the carbon or if the bond glycosidic bond is beta, there may be a chance of non-reducing sugar. Sorry, there may be a chance of reducing sugar. Yes, of course, you are right. If it is beta bond, there will be a chance of getting and reducing sugar. But if it is alpha bond, like as I told you, it's of U. If it is U bond, it is not possible. It is non-reducing. If it is N type of bond, yes, it is an reducing sugar. Are you getting my point? ಅರ್ಥ ಆಯ್ತಪ್ಪ? Can you able to get my point? Can you able to understand? ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ ಇವಾಗ? So they'll ask you, ಇದು ಆಕ್ಚುಲಿ ರೆಡ್ಯೂಸಿಂಗ್ ಅಂಡ್ ನಾನ್ ರೆಡ್ಯೂಸಿಂಗ್ ಕಾನ್ಸೆಪ್ಟ್ ಇದೆಯಲ್ಲ, ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಹೇಳ್ತಾ ಇದೀನಿ ಕೇಳಿ, ನಿಮ್ಗೆ CET ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ, ನೀಟ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ಈ ಕ್ವಶನ್ ಕಂಪಲ್ಸರಿ ಬರುತ್ತೆ. ಹೌ ಕ್ಯಾನ್ ಯು ಸೇ ದಿಸ್ ಇಸ್ ಎ ರೆಡ್ಯೂಸಿಂಗ್ ಅಂಡ್ ನಾನ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್, ಆರ್ ವಿಚ್ ಒನ್ ಹ್ಯಾವಿಂಗ್ ದ ನಾನ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್? ಓನ್ಲಿ ಸುಕ್ರೋಸ್ ಇಸ್ ಯುವರ್ ನಾನ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್. ಸುಕ್ರೋಸ್ ಒಂದು ಬಿಟ್ರೆ ಇನ್ ಯಾವ್ದು ನಾನ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಅಲ್ಲ. ಓಕೆನಾ? Give me a second, I'll take up the attendance. Yes, here I'm giving you. Yes, here I'm giving you a structures of disaccharides. So one is sure all the monosaccharides are belonging to reducing sugar. Here I'm giving a three structures of disaccharides, but I didn't mention whether it is belongs to reducing or non-reducing group. Can you please tell me whether it is belongs to reducing or non-reducing group? See the chiral carbon atom or anomeric carbon atom and see whether it contains free OH group. Free OH group means it doesn't attach like CH2OH. If it is present like that, it is not free. Okay, CH2OH, it's not free. If it is OH, only plain OH, like what you are seeing, the free OH are floating. So if you are seeing like that, that is free OH group. Can you please say whether sucrose, how can you judge it is reducing or non-reducing?